All right. So, hello everybody.
Hello.
Okay, cool. So what we're working on is vertex form. Vertex form. That means that when we start graphing here, we're going to start with the vertex and then move from there. Is everybody okay with that?
Yeah.
Okay, cool. So now we have these funky letters like H and K. H and K are going to be super important for us. The H, did everybody write this down? Did we write down this equation?
Yeah.
Cool. So the H is representative of my axis of symmetry. All right. Ooh, they're excited over there. All right, cool. So we have the axis of symmetry. Everybody good on that?
Yeah.
Now remember, the axis of symmetry, when it comes to a parabola, axis of symmetry is the dotted line down the middle. Is everybody good on that?
Yeah.
Okay, that means that the reason it's so important is because everything is going to be mirror imaged on either side of the axis of symmetry, equidistant from either side of the axis of symmetry. Cool. So the idea now is that when I make my table, and I hope that's in screen, we'll see, whatever, my H goes right here, all right? My H goes right here, is everybody okay with that? And then the K, this guy right here, he's gonna be the other half of the vertex, okay? Remember, my vertex is this guy right here, so it's gonna be HK. This is gonna be my relationship, okay, for that. Are we good so far?
Nope.
Too fast, or are we okay?
No, we're good.
All right, good. So now the idea is that now that I have these pieces of information, let's use the equation that I gave you. We had y is equal to 2 x plus 4, thank you so much, squared
minus
3, cool. Now the question is, what is my h and what is my k? So what's my h first of all?
-4.
It's -4. How do we know it's -4?
Because it's negative.
positive.
Yeah, because the original equation, yeah, the sign flips, that's good. So we know that this is going to be -4. So my axis of symmetry is
Negative.
nice. And then over here I've got what for k?
-3.
Nice. All right, cool. So now we want to go ahead and plug in our information in our table on either side of our axis of symmetry. Are we good?
Yeah.
Yeah, for real? Okay, cool. So then, how do we choose these numbers here? These are,
Closest to -4.
yeah, you want to use the numbers that are closest to our h. Like, don't just automatically go with a 0, because if I plug in 0 here, I end up with 4 squared, which is 16. 16 times 2 gives me 32. Minus 3 gives me 29. That is a high number to like graph up. Is everybody clear on that?
Yeah.
I don't want to go that big. I'm a little lazy. All right? You may not have noticed. So, what numbers do we want to go with then? Instead of,
-2, -3.
yeah, let's go with -3, -2.
And then -5 and -6.
-5, -6. Okay, cool. All right, these could have been inverted. That's totally fine. All right, so now the process is to plug in, let's say like -3 and so forth. Is there a, or negative? It's up to you.
Yeah.
All right. So which one do you want to do?
-2.
All right. So we'll plug in -2. What is -2? It's 2, and 2 squared is
4.
4, and 4 times 2 is
8.
8 minus 3 is
5.
5, and that was for plugging in -2. We get 5. Now, if I've done this right, then these should match, right? And so that means if I plug in -6, I should still get 5. Let me try it. -6 plus 4 is -2. -2 squared is what? 4. 4 times 2 is 8 minus 3 is 5 again. Okay, so that worked out well. Now, do you want to plug in for x? Do you want to plug in -3 or -5? Which one? -3, sure. So we'll plug in -3. All right, -3 plus 4 is 1 squared is
1.
times 2 is
2.
2 minus 3 is -1. Okay, awesome. So now we're going to get to graphing. Now we have a table, and now we're going to go ahead and graph this. All right. So did everybody? Has everybody had a chance to graph this?
Yes.
Yeah, we've all graphed it. Yeah. Okay. Cool. Let me let you do it. Let me let you do it. All right. I'll just edit this part out. This waiting section. All right, and then coming back in 3, 2, 1. Okay, cool. So first of all, what was my axis of symmetry here?
-4.
It was -4. -4 is my axis of symmetry. So hopefully 1, 2, 3, 4. Did everybody make a dotted line on your axis of symmetry? Okay, that's one of the things we want to do. And we know we have a vertex of -4, -3. So it's -4, -3. Wow. Okay, so that's my vertex. Then we're plugging in points like -3, -1. So I'm going back 3, down 1. And then we have back 5, down 1. Notice that it's equidistant from the axis of symmetry. Everybody's okay there? Cool. All right. And then following that, we have -2 and +5. Oh, -2 and +5, and -6 and +5. All right. I kind of did that a little high. Sorry. All right. And then we connect these. All right. You guys hold yours up so I can just see how that went. See, so yeah, finish hitting those points. Good, thank you. Thanks.
Turn my line.
Yeah, double check your spacing. There, just watch out for that. All right, so we want to try to get this as accurate as possible. Okay, should we try another one?
Sure. Yes.
All right, cool. Let's do another one. And so, yeah. Now, this time, let's go ahead and let's start with, let's go with negative, we'll go y is equal to, sorry that my hair is getting in the way of your visibility. That's 2, let's see, x minus 1. Let's go with that. All right. Yes, sir.
So if the h is already negative, will it become positive?
That's correct.
Okay.
Yeah. Everybody understand that question?
Yes.
All right, so if we see that this is already negative, then it implies that we have a positive. So can I check our vertex with you first, please? Can we check our vertex? So what I find is going to be my h and my k. What's my h?
1.
Yeah, my h is 1. All right, so we see that my h is positive 1. And then my k is what?
2.
2. Very nice. Positive 2. Which means that if I have, I shouldn't do this yet. Can I get other x's first? What would you suggest? Yeah.
0. Negative 1.
I heard 0 and negative 1. Okay, cool.
And positive 2 and 3.
Positive 2 and 3. Please, when we come up with these numbers, basically, if I'm looking at one of these as 1 away here, this should be 1 away here. All right? If this is 2 away here, all right, this was 2 away, then this should be 2 away. All right? Is everybody comfortable with that? It should always match. They should be equidistant from the axis of symmetry. Okay, great. Now we go ahead and we plug in. Let's plug in 0. Hey, what's 0 minus 1? What's negative 1 squared? It's positive 1 because a negative times a negative is a positive. So now we have positive 1. Makes it a negative 1 plus 2 is positive 1. Is everybody okay with that?
Yeah.
Do you want me to go into further detail on that? You sure? It's okay?
No.
All right. Just to double check this one, if I plugged in 2, 2 minus 1 is 1, 1 squared is 1. The negative on the outside makes it a negative 1, plus 2 is positive 1. Okay? Would you guys rather plug in negative 1 or 3? Let's do it. All right, so I heard 3, so let's go with 3 minus 1 is?
2.
2. 2 squared is?
4.
4. Negative 4 plus 2 is? Negative 2. So now I've got my data, so I can go ahead and I can graph this. All right? So I have negative, okay. So 2 and then 1, 2. All right, so we know what's my axis of symmetry, please?
1, 2.
Oh, that's my vertex, but my axis of symmetry is 1. So that means I have a dotted line here at 1. All right, and so I'm at 1, 2. Okay, that's my vertex. Everybody's good with that?
Yes.
Okay, and you guys already did that? Yeah. Okay, cool. And so then we're looking at 0, 1. So 0, 1. And we had, what was that? 2, 1?
Yeah.
Oh, what am I doing? It was 0, 1 and 2, 1. Yeah. And then we have 3, negative 2. And we have negative 1, negative 2. So we should be ending up like this. Okay? Wow, mine's not pretty, so my apologies. Does this one have a maximum or a minimum, please?
Maximum.
How do you know it has a maximum?
It's a frowny face.
It's a frowny face, good. Which gave that should give it away that this should be downward facing. Is everybody okay with that? So it should be like an upside down U or a frowny face because that leading A is negative. Okay, if it's positive, it'll make a U shape. Nice. Okay, and so then this is the highest point. This vertex is the highest point, so it's a maximum. Everybody good there? Yeah. Okay, cool. So I think we'll end the video there. All right.